Okay, so when you're simplifying this, of course you could plug this into the calculator and just take the fourth root, but you want to show that you don't need a calculator to get the answer. So this is really 10 times 1, 2, 3, 4, 5. So this is really 10 to the 5th squared to the 1/4. And then you simplify that to really, that's a 2 down there, 10 to the 5th to the 1/2, which is really 1, 2, 3, 4, 5 square root. But you know how it goes, you're going to have to tree. So when you tree it, you know that there's 5, let me do this, so I'll do it up here. So it's really 1, 2, 3, 4, 5. You know there's 5 tens. I'm just going to fake it a little bit. You would tree, and say there are 5 tens. So what do? Circle the doubles. You have 2 sets of doubles, so you multiply that. 10 times 10 is 100. And then you're left with the 10. And since it's the fourth root, plus or minus. So let me repeat what I did in case that was difficult. So what I did is I rewrote this as 10 to the 5th squared to the 1/4. I simplified, and now it's 10, 5 to the 1/2, which is 10. 10 to the 5th is 100,000 square root. But then, of course, I can simplify it, so I found my doubles and what was left one on the inside. Okay, this one's going to be similar. So this is going to be 10 to the 1, 2, 3, 4, 5, 6, 7, 8. 10 to the 8th to the 3/8. You can't fake simplify. You can't just go like this. Okay. So, but I can do that over there. I guess that's fine. And then this would be x to the 9th. But notice how I showed them separately. This is really 10 cubed, x to the 9th. 10 cubed is a 10 with 3 zeros, x to the 9th. It's the 8th root, plus or minus. Okay, so this one was a little bit more simple in my mind than the first one. Okay, the next one. Put the things together that are the same. Normally, if it was negative, you'd move it downstairs. But honestly, if you just add the exponents, that's just y to the 3rd. And this is x to the 1st. So this is negative 11. I feel like the y cubed is the easier thing. And then we look over here. And we're going to put those together. So I've got to show that I can add this plus this. So then I'm going to come up here, 7/3. 1 is the same as 3/3, so they have the same common denominator, and that's 10/3. Here is me showing my work. So negative 11, x to the 10/3, y cubed. Now, if you want to put this in radical form, then this needs to be in radical form, okay? So you need to make sure, and then it just starts looking ugly. So exponential form just looks a lot nicer in the answer, okay? All right, let's go to the next one. So we're going to be doing some treeing, unless you just know this. Square root means we're finding doubles. So 2, 81, 9, 9. So there's a double there. And then some of you are really good. You just will see it, but not everybody will. So there's my A's, 2 doubles. Here's my B, no double. And then my C's I'll put over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So now I have 1, 2, 3, 4, 5 sets of doubles. So all my doubles go on the outside. A 9, 2 A's, no B's, and 5 C's. And then what I didn't circle will go on the inside. And that's what's going to go here. So I've got a 2, an A, a B, and a C, because it's square root, plus or minus. All right, this time we're trying to find the 5th root. So this time we're trying to find piles of 5. So if I tree this, this is 2 to the 6th. So 1, 2, 3, 4, 5, and 1 left over because I like to do my piles. So there's a pile right there. You could tree it and do that. I've got 3 X's, no piles. 10, I've got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I've got 2 piles. And then Z's, 1, 2, 3, 4, 5. And then, oops, on. 1, 2, 3. Let me show these are z's. So there's another pile. So remember what I'm going to do is I'm going to take all the ones that are not in there. So 2y squared z. And then don't forget to write the fifth root. I think that's an easy mistake to make. I'm left with a 2, 3 x's, and 3 z's. And it's the fifth root, so there's no plus or minus. Now you do not have to do piles. If you want to, like for the y, you could go y to the 10th to the 1/5. Maybe for this one it's more obvious, and then you show that that's the y squared. If you want to show this as 2 to the 5th, 2 to the 1st, that's fine. Show that it's the 1/5. Okay, just make sure you're showing your work. All right, next one, negative 32. You can tree that, but hopefully some of you will, oopsies, I put 25. Hopefully some of you will realize, when we do it enough and enough, that you'll know that 2 to the 5th is 32. That's gone. Negative 2 cubed means negative 2 times negative 2 times negative 2, which simplifies to negative 8. All right, so there's different ways to do this. You could tree this, find piles of 6, tree this, find piles of 6, but I know this is 2 to the 6 to the 1/6. This is x to the 12 to the 1/6, so that's 2, that's gone, and so we get 2 over x squared, even root, plus or minus. Okay, next one. Now, looking over here, I saw that the 6th root of 64 was 2. So if you multiply that by 2, that's another one. So this is really, 128 is really 2 to the 6th, 2 to the 1st. And I know this is really x to the 12th x. If you're not sure what I'm talking about, you'll do your tree. 2, 64, 2, 32, 2, 16, 2, 8, 2, 4, 2, 2, 1, 2, 3, 4, 5, 6. There's my pile of 6, and there's the one left over. With the 13, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There's my 2 piles, just like that shows up there. Just make sure you're showing your work to the 1/6. So that's really 2, 6th root of 2 over x squared, 6th root of x. Okay, here's where it's going to get a little bit more difficult. So I don't have any problems with this. Oh, and there's going to be a plus or minus in there. I don't want to forget that. Okay, let me show that in the previous problem. My issue isn't the numerator. My issue is the denominator. So if this is piles of 6, but I only have pile of 1, I need to give 5 more. Because once I give 5 more, that makes a pile of 6. That'll turn into an x. And then I have an x squared. So now it's x cubed in the denominator. But what I give to the bottom, I have to give to the top. So I just put those together. 2, on the outside, 6th root of x to the 5th. And don't forget that plus or minus that we had in the beginning. Okay, that one's a workout. All right, you're going to have some problems on your test that are going to ask if it's true or false. So you want to prove that either make this side look like this side or make this side look like this side. You need to show equality, okay? Otherwise, I can just use my calculator and cheat. So, and that's fine, but you need to show your work. So I'm going to make this look like this. So I know 125 is 5 and 25, which is 5 and 5. So this is the same as 5 cubed to the 1/2. Distribute that. 5 to the 3/2 equals 5 to the 3/2. I have shown equality. The left side looks like the right side. It's true. Let's go to the back. All right, so we want to solve for x. So since this is to the 1/5, I'm going to take to the 5th power so that that goes away. X plus 8 equals 2 to the 5th means 2 times 2 times 2 times 2 times 2, 32. Subtract 8, x equals 24. I can check by plugging it in. So I can go 24 plus 8. You don't have to do this, but I'm just showing you. To the 1/5. 24 plus 8 is 32. 32 to the 1/5 is 2 to the 5th to the 1/5, which is 2, so I did it right. So this is your answer, but I just wanted you to see how to check it. All right, this one's similar to this one, but there's a 4 there. Divide by 4. 81 equals x plus 5 to the 3/4. My issue is always the fraction. Get rid of that first. okay? And I'm actually I'll keep it 81 to the 4th. I don't know what that is right now. And then now I'm going to take to the 1/3. So now this is, ooh, you know what? It's fine. This is a really mean one, and I didn't mean it to be so mean. This is 3 to the, you know what? I'm going to change this problem. Sorry. Make the original problem to the 4/3. Okay, so let's start again. Divide by 4, divide by 4. 81 equals x plus 5 to the 4/3. And actually, you know what? I can just multiply by the reciprocal. So let's take that to the 3/4. Let's take that to the 3/4. So then that's gone, and I'm left with x plus 5. Now this is a mess, but I know that 81 is 3 to the 4th to the 3/4. Now there's a 4 on top and a 4 on bottom. Bye-bye. 3 cubed equals x plus 5. 27 equals x plus 5. X equals 22. Okay. All right, let's go to the next one. Square both sides. A mistake that you're going to make, this isn't the mistake you're going to make, but when you square this, you're really boxing it out. When you box it out, you get x squared minus 16x plus 64. Set it equal to 0. X squared minus 17x plus 68. All right, so this one's a little bit more difficult for me, so I'm just going to pick up my calculator and go 68 divided by 2. 2 and 34? Nope. 68 divided by 4. 4 and 17? Nope. 68 divided by 6. 68 divided by 7. 68. Something happened here. Oh, because I don't know how to add. Let's make that 70. So if something happens and you can't do it, either I made up the problem wrong or you made a mistake like I did. So two numbers, 10 and 7, that's a lot easier. 10 and 7. But now I have to actually check it. If I plug in 7 here, 7 minus 8 is -1. A square root can't equal a negative, so that's not an answer. You just get 10. Okay, let's do this one here. Square it, square it. So 2x equals. Don't forget to square the 5. 25 times 8 plus x. Distribute, distribute. 25 times 8, 50 times 4, 200 plus 25x equals 2x. It's okay to get a fraction. 200 equals -23x. X equals 200 over -23. Actually, don't be like me. Put that negative either in the center or the top, not the bottom. Yes, I'll mark it wrong. Okay, this one's the biggest workout, and we're going to go to the minute on this one. So this is 2x to the -4/5, and I'm actually going to rewrite this. 64 is 2 to the 6th, but it's at the bottom, so I'm going to move it to the top. Okay? Now, my issue first is this fraction. So I'm going to multiply both sides by 5. By doing that, we get 2x to the -4 equals 2 to the -30. Okay? I think some of you agree that kind of what the issue could be is that both of these are negative. So I would multiply to the -1st power. Okay? And I get 2x to the 4th equals 2 to the 30th. And then I distribute. I'm actually going to leave that like this. Oops, sorry about that. X to the 4th, and I'll show you why. Because I'm solving for x. Okay? And I notice there are 2's on both sides, so I'm going to divide by 2 to the 4th. I know I'm out of space. Sorry about that. And I'd be left with x to the 4th equals. Remember, when we're dividing exponents, it really means we subtract. 2 to the 26th is still ridiculous, I understand. Take this to the 1/4 power. So you're doing, this is a pretty mean one. I probably should have done a better job making this up. But then I'm left with x equals plus or minus. So I'm going 2 to the 26/4. So what I need to do is find piles of 4. Some of you know that it's that there's going to be